Hello everyone, and well, welcome to the first video that I've done of this sort, and that is where we are going to try to hack Manim a little bit. If you're not familiar with Manim, it is a Python-based animation library that is used and I guess made famous by its author, Grant Sanderson, who has the YouTube channel 3 Blue 1 Brown, and it's a really nice piece of software. And I decided to try to make something in it, and well, I needed some features that it didn't have. So I thought, okay, well, I'll try to write it myself. And then I thought, why not invite you along for the ride? Because I've learned a lot in the process of doing it. And so this is something that I plan on opening a pull request for and contributing back. So why not show you the process? And with that said, I think we're just going to jump in. And I've got a couple things set up. One, I already have Manim cloned from GitHub, and so I've got a working copy that I can hack as I need to, and I've got a file set up that is just kind of for my rounded corners. That's what we're going to be talking about today. And let's just at least state the problem. And I've got a video here. This is again a Manim generated animation, but it's not math. It is, I'm using it to depict a piano keyboard, and it is showing, I don't even remember what what chord it has highlighted. It's probably one that includes a lot of black keys. Yeah, okay. So this is something I wrote. And specifically, what I want to point out is the rounded corners. Pianos naturally have rounded corners, but I don't want rounded corners on all sides. I like them at the bottom, but I don't want them on the tops. And because then it gets this sort of weird look to it. And maybe that's not a problem, but I just want it different. And what is this chord? D flat. Yeah, that would be 7, 11. Oh, sorry, 7, 9, 11, 13. So it's a D flat 13 chord, in case you're dying to know that. But anyway, yeah, so I want not all corners to be rounded. Manim has, when you create, you can either create a rectangle and then call the round corners function, or you can just create a rounded rectangle, which is what this is doing, and give it a radius to use, and it will create the rounded rectangles. But I want to be able to say, do the first corner at this radius, maybe 0, and the next one at whatever radius. Okay, so that's the intent that we're going to be working with, and we'll come back to this and probably re-render it at the end. So what do we need to do? Well, first of all, let's get a scene that we can work with, and there's nothing here. There's nothing in this file rounded. And so I know I'm going to need to say from Manim import everything, and I'm using the Manim Community Edition. There are different versions, and I just happen to choose the Community Edition, and that's the one I'm going to be doing this for. So, and what we're going to do, let's have a class that is our scene, and what did I call this? Rounded? Rounded. Yeah, sure. And it inherits from scene, and of course this is Python, and yeah, that's 4 spaces. That's okay. That's not the end of the world. I don't want Windows line endings. I want Linux line endings. That's just a personal thing. And we need what I always forget. I'm looking at an old thing with the scenes here. I think it's construct, something like that. Yeah. Construct, and it's a method on it, so you need to pass it itself. And all that I'm going to do, I like having the background color. This is one I saw demonstrated on Manim, and I actually kind of like it. So E2. That should have been a 6, I believe. Yes. And then self dot weight. Sure, why not? Now, I said I was looking, this is actually I was looking at the keyboard thing. I have not done this ahead of time. This is live coding. You're going to see me make mistakes. That's normally my style. You'll find other videos on my website, on my channel where I do the exact same thing. And besides, I kind of want you to see the process. That's the goal of it. All right, so I've created this, and this should generate a file for us. And if I go, let's see, this is in the piano one. Let's not go on piano. Let's go into educational, right? This is Hacking Manim. This is my splash screen that I created it in Manim. And now there's this one. Okay, so what is my command? It's Manim. I want my quality, sure, high. Why not? High quality and rounded.py, and there's only one scene file in it, so I can just run it, and it'll run that one by default. And okay, it says that it created it. There it is, media, videos, rounded. There we go. And there's nothing there. It's 1 second long of nothing. That's fine. All right, let's go back and let's I'm going to say RR is equal to rounded rectangle. I don't remember. Well, this is what... don't use that browser. I'll use this one. Rounded rectangle, go, and it should bring up the community website, which it does right away. And we can see the command corner underscore radius. Okay, so corner radius equals, and it said 0.5. 0.5, sure, that's fine. And I'm going to do self dot play fade in that weight. Excuse me. And my screen sharing app was thinking I was abandoning it, and I was like, no, I'm still using this. Don't shut it off. Anyway, all right, so did that, hit save. I'm going to rerun the command. I have made that mistake more than once typing the word rectangle. It's like, for some reason, my brain doesn't think that there is an L there. And if we run it, oh, okay, so it creates it white because it thinks black, because by default, Manim is on a black screen. So color equals blue. And what we're about to do is, I said I was going to try to hack Manim, and I am, but I'm not going to do it in Manim first. Here we go, do this. There we go. We've got a blue rounded rectangle, and we see that. All right, so what I want to do is I'm going to create a class that's called R. This is only temporary. I don't care. It's rounded. Rectangle, and it has a... I always forget the syntax here, so I have to look it up. I don't program in this that often. That is, I don't program in Python as often as I used to. And I'm going to do kwargs and just super dot the dunder init and pass in kwargs. Sure. Now that should still work if I just call R. And you'll notice I do this a lot. This is my habit. I will make small changes, save, see if it still works. Let's see. 0 positional arguments, but 1 was given. Oh, of course, because... Wait. It should be self. That's why. Should have the exact same thing. We do. Now, some of you who have worked with Manim may know that there's a command line. I think it's if you add -P for preview. If I try to run it, I'm doing this in the Windows subsystem for Linux 2, and it's just not set up to play it. So I have to do it this long way until I find a good workaround. So there we go. All right. So I'm using my version, and it's just calling rounded rectangle. Now, why would I do that? The reason is because, where was that? Where's my Firefox window? There we go. Rounded rectangle. If I look into it, I can just pull up the source here, and we'll see what does it do. It calls its own parent constructor, which it's of the type rectangle. You probably can't see that well. Let me make this larger, shall I? There we go. And it sets corner radius to whatever you passed in, and then it calls this round underscore corners class. And that's inherited from somewhere, so we're about to find out where that is. Round corners. Hello? Oh, there it is. It's up under polygram, which I think if we round a rectangle, we'll go to rectangle, which will go to polygon, which will go to polygram. That's fine. And I can look up this, there we go, round corners. And I want to copy this. Now, I also want to show you that I can go to Manim here, because like I said, I've already cloned it. Manim object geometry, and it's under, is it geometry? I think so. Well, this should be polygram, round. Yeah, round corners. All right, I'm just copying that, and I am putting it in mine. So it should use mine as opposed to, I'm just going to get rid of this help text because, well, I don't need it for right now. It's just getting in the way. That's the goal. And if I say, well, I can't do it there. There, had to indent. Howdy, I'm from Texas. If I say that, run it again, we should see it print the word howdy at the start. Yep. Oh, and it's doing the -P. That's fine. But right there, that's what I want you to see. Howdy. So it's calling my version of the function. All right, so let's get rid of that because we obviously don't need it. All right, and we're going to see how this works. I mean, it's a Python method. Self is self-explanatory. Radius is the value that we are rounding to. All right, so if radius is equal to 0, return, so it doesn't make any changes. That's fine. Then it's got points. And I've had to do some digging into how objects or this is structured. And basically, in each of these objects, there is a set of points, right? And it's actually, well, get vertex groups. Yeah, that would be fine. Adjacent in tuples. Let's do this. Let's say print self dot get vertex groups, and there we go, and make sure we don't have the dash p here because we don't need that. Okay, so that's our vertex groups now. You notice it's an array of arrays, and what it is in Manim, and I may have my little thing here, 2 vertex groups. Well, here it's just a rounded rectangle. There's 1 vertex group, and I realize I've been showing a blank page all this time. Don't let me do that. I've probably just jumped forward to this because I realized I was talking and not showing this image. So the point about the polygram is that it has vertex groups, and a vertex group is a closed loop of vertices, generally speaking. It doesn't have to be closed, but I mean, it could just be a line. But anyway, and in this case, we can see a hexagram getting created that is one set of vertices that makes one triangle, and then another set of vertices that makes another triangle. And so if we look at the code, I printed self.getVertexGroups, and we see that it is an array of arrays of points. And since this is a square, a rectangle, it has 4 points, four corners. That's fine. All right, so I'm going to delete that because we don't need it. And so we're looping through that, and now we're going to say for that set of vertices of a certain loop, we're going to get the adjacent n tuples and get them in groups of 3. So now I think I can show you if I've got a square here, and I don't know which order they're going to be in. It doesn't matter. 0.1, 0.2, 0.3, and 0.4. I'm hoping that's showing up. Yep. The adjacent vertex groups are going to be like 4, 1, 2, because we're asking for them in groups of 3. 1, 2, 3, 2, 3, 4, and then 3, 4, 5. So you can look at it as, or think about it as, for each vertex, it will give you what's right before it and what's right after it. Okay? Or I'm sorry, from your perspective, the other way around. What's right before it and what's right after it. And so that's what it's doing. And it's getting them in these variables v1, v2, and v3. And then remember, each one of these is going to be a vector of an x, y, and z coordinate. And we do a little bit of linear algebra here. v2, which is the middle point, minus v1, and v3 minus v2, and that's to get the vectors, which direction it's pointing. And then normalize the vector. That's our unit vector. Okay, that's fine. Find out the angle between those 2 vectors. And then we get the sign of our radius. Oh, this is interesting. So in my example, we see here that my radius was positive, so it's like that. But if we do in my lovely little thing, let's go back down to my scene and give this a negative 0.5 and rerun, regenerate. There we go. And it now has an inset. Okay, that's fine. Not bad at all. Okay, so we just figured out the angle, and we use the radius with a tangent of something to give us a cutoff length. And then cutoff length is basically how far back. So to go back to my lovely drawing, it's the idea of if I am looking at this corner right here, all right, if I'm looking at that corner, then what I'm going to do is I'm going to need to say cut off at this point, cut off at that point, right? That's my radius, and create an arc here. Well, that's not very rounded, but I'm also drawing at a weird angle, and I'm not an artist. So that's the goal, and I just realized I was covering up the 1, 2, 3, 4. My apologies. There. Anyway, so what that piece of code is doing is it is saying, give me that cutoff length, which is this right here. That's the cutoff length. And all right, go back to the code. We've got the cutoff length. We get the sign using the cross product. Again, more linear algebra. It's working, so I'm not going to touch that. And then we create an arc between the points, and that is V2, that's our middle point, minus the unit vector times the cutoff length. So the unit vector is the direction it came from, basically from the preceding point to the middle point. And so I'm backing up by my cutoff length. That's the point of this. So I'm going to the point, or rather here, I'm going from if this is my V2, this is my V1, and this would be my V3. I am doing some math to go back to that point, and I should probably do it in a different color. Oh, that's the sparkly color. And this point. Yeah, that's what the math is doing. And so I'm creating an arc, and then I'm creating a list of these arcs, because that's what I'm doing. So for each vertex group, I'm getting the sets of tuples, and for each set of tuples, I'm creating an arc. All right? So then what do I do with that? I have this arcs, and I put the last arc first, and then I do the rest. So we start from the last arc and go through the rest of them. Oh, I think I know why. Okay, so okay, there it is, import the line. Now, arc 1, arc 2 in adjacent pairs. So what this did right here, arcs, is giving me if my list was 1, 2, 3, 4, what it's doing is it is putting the 4 first, then 1, then 2, then 3. Okay, so that's what this line is doing. Yeah. And why is it doing that? Because it uses that to call adjacent pairs. And adjacent pairs, I found this out by just reading the source code, is the exact same as adjacent in tuples, but with a 2 instead. So what is it going to give us? What is adjacent pairs going to give us? Well, to go back to the whiteboard, it's going to give me a list of 4 and 1, 1 and 2, 2 and 3, and then 3 and 4. That's right, it will link that last one and the first one as well. So it will give me these. There we go. These pairs. All right. Go back to the code. So for each one of those pairs, what are we doing? The new points, this is an empty list that, what do we do? At the end, we set all of the points as new points. Okay, so new points, we're accumulating stuff. What are we accumulating? First of all, the points from the arc, if this is like the previous and then the next. So we add the points from that arc, and then we create a line from the ending of arc 1 to the beginning of arc 2. We've got this weird length ratio, which is the length of the line divided by the length of arc 1. That's interesting. And what do we do? In the line, we insert in curve. So I think that this is subdividing the line by the however many curves it has in it. I don't know what the default is. We'll have to look, times that length ratio. Oh, so it's saying the length of the line divided by the length of the arc. So if the line is twice as long as the arc, then give me twice as many anchors. So it's making sure that the anchors, what it says here, make sure the anchors are evenly distributed. Okay, that's what it's doing. And then once we figure out what all those points are, add those to the line. And it loops through. So going back to the drawing board, quite literally, we're going to have a list of arcs. That's each one of these arcs. And it's going to first get the points from the arc. Then, that is a really ugly way of drawing that. Do I have maybe a blue? There we go. First, it's going to do the corner. Then it's going to do the line in between. Then the next arc, the next corner. Then the line in between. Next arc, line in between. Next arc, and then the line between. Okay. Let's work with that. So what do we want to do? We want to be able to say, okay, so CSS has done this forever. In short, what I want to do is I want to be able to say, instead of a box like that, I want to be able to have a box that has a rounded corner and a rounded corner and square on the top. That's really ugly. Or even more interesting is maybe a box that has these cutouts on one side and then rounded on the other side. Maybe that, where they're negative on one, just different values. And this doesn't just have to work on boxes. Later on, we'll see that it can work on stars and other things as well. So that's the goal. Okay? So what do we need to do? First of all, we need to pass in, instead of that, we need to pass in something else. had a slight mishap with my recording software. Just caught on to that fact. Where am I? All that I've done is I was thinking about passing in a list. And so I've got this list of radiuses, radii, and so what am I doing? I also was printing out the length of the vertices. And for the moment, let's just, because I don't remember if you've seen this already, but if I do 0.5 and 0.5, I think this should work, even though I just got an out of memory error on everything else. This should work. Okay, that seems promising. Is this? Yeah. You know what? What about negative 0.5? Okay. I'm happy about that. And it is repeating. So it did a 0.5 and then negative 0.5. And so what changes did I make? Not very many. Printed out the length of the vertices before and after. In fact, let's see what that is. Right now, the before is 4, the after is 116. All right. So I decided to come up with a radius list. I wrote this. Repeat the radius list. So I'm, saying it's, there's a radius list, and I'm saying if the radius is just a float, then make a list that contains that radius times the number of vertices. So remember, we're going through each vertex group. So for each vertex group, we're creating this. So create a list, the length of the vertices. Otherwise, multiply the number of lists over and over by this. I'm saying the length of the vertices divided by the length of the radiuses, and then take the ceiling of that. And I had to add from math import ceil, right, for the ceiling. And so that means if there's 5 vertices and I've got 2, 5 divided by 2 is 2.5, and then but the ceiling of that is going to be 3. So I've got 2 times 3 will give me 6, which is more. So it's going to be equal to or more than the length of vertices. And then I wrote this little zip. Now before it was, well, in fact, I don't even need to show this. I can, well, I only have to do that here. I can show you here. Before it was just v1, v2, v3 in the adjacent n tuples of vertices. And so it's just, asking adjacent n tuples to pull them all out. And I added to it, not just that, but I said, but take my radius list, zip it up with this, and zip will truncate to the length of the shortest list. So if my radius list is too long, that's okay. It will pair it up with each of these tuples, and that's how it is rotating through. All right, so that's fine. That's working. The problem is what you just saw. And that is if I say, instead of -5, if I say 0, and that should be a corner. I'll run this again. And it tried to allocate 5.01, I guess that's petabytes, for an array of that size or that shape. Why? Repeat indices, that's in vectorize m objects. Rounded.py, this is mine, so line 60, and it is here. Insert, and it's probably in that. Why would that be? This is mine, yeah. Arc1, the number of curves. We don't know what that is yet, but we could print that out. But times the length ratio, and I bet you that's it. So is my length ratio really big? Line, the length of the line divided by the length of the arc. And if the arc has a radius of 0, any number divided by 0 is probably pretty big. That's what the problem is. So what's our solution? What can we do? Well, okay, fundamental assumption. Before, let's take this out. There. Insert in curves and just add the line points. What's going to happen there? All right. So I've got a rounded, a corner, a rounded, and a corner. What if I have multiple corners in a row? I can find that out by just adding another 0. There, you know, they're fine, all zeros. Yeah. And notice, by the way, instead of 100 and however many, now it's only got 22, and now it's only got 15. Okay. Did I got one rounded corner, and I guess, by the way, that's the first corner. For sure. One rounded corner, and the rest regular corners. All right. So what are we trying to do in doing that? What's the point of this? Find out the length ratio, which is the length of the line divided by the length of the arc. And then multiply that by the number of curves in the arc to get the number of curves in the line. That's standard algebra. And if you can't visualize it, then I'll draw it here. We're saying the line length over the arc length. The arc length times the arc. It says number of curves, but that would be the number of points, or Bezier curves. And what will that give us? Well, just simple division of both sides by, it will give us something, right? So if it's line length over arc length is now equal to x over arc count, that's going to be then the line number of vertices. That's what it is. And or curves, Bezier curves, which that's what I said going back a while ago. That's what it's doing here. So I'm trying to insert an infinite number in short here. So how many should it be? if the goal is to evenly distribute the anchors, then what if I, before everything, computed what the average is? Would that work? So where would it be? Arcs is my list of arcs in one, but that doesn't matter. I could do it before. I could do it right here. The average length of each curve I need, first of all, a list of the non-zero length arcs, and that's going to be a list of all arcs for arc in, well, I'll just say arc. Arc in arcs. If the So I'm using arc points. What's the length of each? Okay, this is going to error out on me again. I don't care. I'm going to say for arc in arcs, print the length of arc points. And it's still going to give me an out of memory error, but I'm just trying to, I want to see this. Okay, so the 32 is the number of points. Oh, well, that tells me how many vertices it has, because each vertex or each segment is 4 points, right? You've got your 2 anchor points and 2 handles. So that's, each one is, well, 8, of course. And so these only have 1. So if it's greater than 4, yeah. So let's say the non-zero length arcs are all the arcs if the arc dot points is greater than 4. Okay. Now, what do I want to do with that information? If I have some, then the average arc segment length is going to be that's how about this? Length is equal to, and can I do the sum of arc dot get arc length, Length, know that that exists because it's down here. For arc in non-zero length arcs, and total curve count is equal to the sum of arc dot oh no, it's going to be the length of arc dot points for arc in. What's it trying to do there? That was weird. Arcs divided by 4, right? And then the length per, let's call that the average length per curve, is equal to the total arc length divided by total curve count. Why did I type a colon? I don't know. That's fine. Else, these do not indent to there. Else, let's just say 1 for right now. All right. Now, what does that mean we can do? We don't need the length ratio anymore. But we can do the line length divided by average length per curve. And that would be a float, and so something tells me we need to do a ceiling of that. Is that right? It's length divided by the average length per curve. Should work. Probably forgot something. Evidently I did. What line is that on? Oh, I need an equal sign there. That made sense to me. Oh, that should be the length of arc dot points is greater than 4. I told you I'm not copying this. Okay, so we started off with 4. We ended up with 129. What does our animation look like? We have one rounded corner. what happens if we have 4 rounded corners? Four to 120. Okay. What happens if we've got that? So it just said basically change it for each one. 66. Because it's taking the average and, oh, if it gets too big, I see what it's doing. I've seen that behavior before if your radius is too big. So the other thing, I want to check something really fast. Radius is equal to 0.5, and I'm going to do this as a rounded rectangle. Let's do 1 and 2 and V group of RR1, RR2, arrange down. Okay. And here, green. I'm just wanting to check something really quickly. Oh. Okay, so I have 3. What I wanted to see is, does this look right? And you know what? This is a 1.5. I want to change that to 1.5 just to make sure that I'm doing the exact same behavior. 1.5. Do this again. Yeah, so I'm not crazy. It's right. It's just having a large radius. And is this correct? Yeah. So, starting out, we've got this working. Yeah, I'm intentionally doing a negative. Hey, it looks like a ticket. Yeah, that's fine. So what is making me uneasy here? I don't like how much that's doing. I would like to be able to say, don't wait a second. Okay, so when I'm creating my arcs, Wait, because I remember checking this out in the 3 blue 1 brown repository as opposed to this. Because I was just seeing, because sometimes there are changes in one not in the other, and this one has, it seems like this one has the more recent code, but one of the things it had was when it called round corners, or the arcs. Where are the arcs created? Vertices. Arc is arc between points. Okay, I need to see this. Start in angle, radius, and any other keyword args. Endpoints per curve. That's going to be 4. Look at the source. So what are we doing? It's inheriting from arc. If radius is none, give a default radius. Is that what it's saying? Yeah, if it's not none. Radius, angle, and any other keyword args. Points at corners. Set points as corners. Again, I evidently went too long without drawing something. My drawing software decided to try to shut down. When it calls its constructor for arc, radius starting at num components 9. If I pass in a num components of something else, two, would that give me just the 2 endpoints? Oh, that really takes it down 19. What does it look like? Huh. Not a big deal. Okay. So what I'm saying is should it be num components is equal to 2? I'll tell you why I'm thinking that. Because in GitHub 3 blue 1 brown Manim there. Again, this is a different repo, and his is in Manim lib. Let me make this a little larger so you can see it. MObject, different structure. So, but it should be in geometry. And round corner. So the radius is listed as optional. That's fine in his. And it will default to 0.25. I kind of like that. I might add that in. Don't know if I can do it in this merge request or if it's too much, but all right. But all of this is the same, but he does an in underscore components F2. So he just hard codes it. And doesn't do the line thing. However, again, I looked this up. So if I look it up in GitHub Manim, not for the Manim Community one. How do we go about doing this? Manim M object. It's under geometry and then polygram. What is this going to be called? Round corners. There we go. If I get blame, beautiful tool. There we go. Rounded corners. This was all put in. Oh, wait. What I care about is. Yeah, all of this happened. Improve the structure. There we go. So I'm going to go to that and say. Geometry. Wait. Oh, the file was deleted. I'm loading it though. Can I go to there? Can I say view the file? Okay, so this is the old geometry.py. Blame. Rounded corners. Rounded corners. Rounded corners. Rounded. Okay, so here's a rounded corners function. And this was added when it reworked the polygon inheritance tree. Okay. Geometry. Oh, I needed the blame. So May 19th of 2021. Round corners. But that's the example. This is the code. Oh, did I not? I didn't do the right thing. Oh, view the blame prior to that change. Okay. Okay, here's round corners again. Now we're getting, that was enforcing formatting. But here's this, and there was a comma. 5 years ago, 3 years ago. So this is pretty old. And who did this? Grant Sanderson. 5 years ago did this, and 3 years ago. And let's just see what was there at this time. Here's the round corners. Oh, before there were comments. And yeah, back 5 years ago, it says fix the border. What bug was it? Oh, it doesn't say. It was old. That's when I guess he figured out that about how to use the sign. Okay. Yeah. What's the point of all that? It hasn't existed, but it does exist in his. This is the 3 blue, 1 brown one. And if we look at his round corners, now that I know how to navigate through this quickly, blame, round corners, get to number of components is equal to 2. That was 4 years ago. So it was more recent than to work with quadratic Bezier curves. I think it was just never put in this one. So I'm going to leave it. And in his, he doesn't have that, does he? Arc between points? No, he's got a completely different way of doing this. Wait, I think is that the old way, though? Yeah, so insert in curves. That was done 5 years ago. And if I see what was there before then, again, round corners. Here's round corners. It was this approach. So Manim CE had the same approach 5 years ago. Subpath, and then line 2. Oh, append points at line 2. Okay. I mean, that's fine. So, oh wait, no, wait. Am I both of these are in manim/manimlib? Oh, no. You have to look at the URL. This one is the Community Edition, long time ago. URL, this one's the 3 blue, 1 brown one. So, but last month he said, what change? Do we have add subpath? I may just take the same approach. You know, I've got an easier way. I don't want to lose my spot there. So I will just open up another window and go to mount d manim get grep vectorized m object. Let's see if it works, shall we? Still need all of that. So this was basically, so he used to have add line 2, arc2.get start, arc2. So the only difference is add subpath instead of append points. That's the only difference. And then all the rest of this may be going away. Let's see what we broke. We only have a green one. That's not good. So I'm assuming, wait, was it arc1.points? His is dot get points. To the attribute normally. Okay, it doesn't like that. Okay. So for whatever reason, it's not liking that. But the other thing is, I kind of like the ability to have the number of to spread out your your number of vertices, but maybe it shouldn't happen by default. Maybe that should be something that gets passed in. So let's do this. Let's say radius, and let's say evenly distribute what's the word? Anchors. And that should be a, is it bool? Yeah, bool. That's what I was looking for. Equals I'm going to default to false because that is his default behavior basically. And then I also want what was that number? When creating the arcs num components. So this needs to be int equals two. Going to pass in num components. All right. Do I want to have this the the same thing, the same way? What I mean by that is, do I want them to be able to pass in a list like they can do with the radius? I don't think it's a big deal on that. I don't want to I don't want to complicate it too much. Either way, if I, well, got a radius list. I don't want it to be num components. I want it to be per arc. Components per rounded corner. That is better. It's longer, but okay, and that only gives us 19. That's pretty good. And evenly distribute anchors. That's what we need to fix. So think I would rather put this here. I no longer need length ratio. So, if evenly distribute is false, then it won't even calculate it. And wait, so if it's true, it will calculate it and it will do that. But otherwise, it won't. So now we just doubled it to 8. Let's see, does it look like we're expecting? We still have our 0, our insets, well, one and outset one. There. Well, okay, evidently I don't know how this works. 0, 1. Is that right for 0.5? It just looks so squished, but I think it's just because it's long. Yeah, whereas if I just have a or just a single. Yeah, that's all. It's all matching. All right, I think I like that. We need a way to pass this into rounded or into R, but I just gave it away mentally. We've got to fix this. We've got to now put this in rounded rectangle. So first of all, rounded rectangle. Is this? Oh, round corners. Okay. So if radius is equal to 0, all the way down to, oh wait, I don't need to print the length. Don't need to print the length. One last time, just make sure. No errors. Didn't get an error. So if radius is equal to 0. All right, I just copied that, and now I'm going to polygram. If radius is equal to 0. Round corners, okay. And then what do we need to do? We need to add these two options to polygram. Oh wait. All right. I know I just kind of stopped, but it's because I'm thinking. What I'm wondering is, should I change rounded rectangle at all? Do I don't think I'm going to. Rounded rectangle. So it's just corner radius. Oh, that needs to change. Oh. So this could be a float or a list of float. And I need to add that to the rounded rectangle as well. Or round corners. Radius is a float or a list of floats. And I'll add the help text as well, but for right now, we want to see if this is working. How do we do that? Well, we're going to say now it's a rounded rectangle. First, does that work? Get two rounded rectangles. Yep, that's what we expect. So through a 0 in there, through a positive number, well, it's a, oh, ceiling is not defined. The question is it the style? Annotations. NumPy, color. I don't know if there is a thing about what I can use and not. We'll find that out. And we had a negative number, a 0, a big positive number, and that. And it is working in Core Manim. Well, Community Edition. I like that. Yeah. So, not this window. I've only modified the one file, and what have I changed? Oops, they won't like that. Well, neither do I. Vim had me spoiled. It would automatically remove that kind of stuff. Oh, for the... Wait, what? On repeat the... There it is, yeah. what I want to do now is I want to check it with two things. Okay, we'll do two different checks. The first one is I'm going to back out of this. And go into, is it educational? Nope. My piano one. Which video did we look at? We looked at media, videos. I think it was keyboard 1 that had all, yeah, that had all the rounded stuff. And I'm going to have to open that file, aren't I? Not that one. This and what I care about is keyboard 1. And, oh no, it's not going to be this. That is, I need it to be my Manim keyboard thing where I do all of the lovely little work of building it. And I had this special rectangle where I was playing around with, but didn't get it working. So let's see. White keys, corner radius are now going to be 0. And then this is going to be all right, so that should work. And what we said, it was keyboard 1, right? Manim quality high. Episode that. Keyboard 1. Keyboard 1. There we go. Look, we've got a flat top across the top. And yeah. And I'm sure my other, if I did keyboard 2, I don't even know what's in it. Yeah, whatever I was doing before took forever to process. So this is a lot better. Evidently keyboard 2 is kind of short. Oh, it's where I was playing around with putting stuff, yeah. But what I care about is it works. That's a good thing. So what we now can do is we can go back and I can turn this into a proper merge request because that's all the differences. I need to add a bit more to the documentation, but I'm going to do that. And, so why would we care about this? I'm glad you asked. Let's do, what was it? Not add. Round corners. There we go. So there's a star. Let's just copy this. That should work. This is the first one. And I need to go back. Where am I? PWD. I think it's educational, right? Is this hacking Manim? Yep. 001. Yeah. Manim. Quality high. Round. Did I save it? Yes, I did. Let's see if that works. And where did I put the file browser? There we go. We need to get back. Okay, so that's what they are. For the first one, let's do radius of 0.1 and negative 0.1. And for the second one, I think I want it to be .5, if that's too big. We're about to find out. Okay. Now, I kind of like the fact that that is very, very slight. That's interesting. Okay, so definitely to fix this, 0.25, and this will be 0.5 is definitely too big. I guess 10. See if I made any mistakes. This is so that they're all different in the second star, and then this one hopefully will have a cool little look to it. Yeah, a little bump there. And then this one, it's like each step gets more and more. And it's just that inner one was too big. All right. Yeah. I like that. I want to negative 0.3 and that's good. This was not possible until this patch. So yay. Okay, cool. Yeah. Well, I think that is a good place to stop, and now I've got to edit all the videos for the times where I just messed up in showing this stuff. Didn't have it on the right screen. All right. Well, I'm going to wrap this up. Thanks again for watching, and if you're just interested in Manim, hopefully this was, entertaining or maybe painful to watch. Never know. All right, thanks. Have a great day, and bye.